Hey guys, welcome back. In this video, I will mainly talk about the beam steering concept uh, in analog beamforming. So, in the previous video, I was mainly talking about various aspects that are required to relate the precoding based beamforming. That is, especially the beamforming in the direction of the beam vectors in the digital domain. I wanted to link that with the RF analog beam, right? So for that, I mainly spoke about the beam steering concept at this point in time. So we will try to derive the phase shifter values, and we will try to discuss about many aspects which we should know when we steer the beam. So coming to beam steering aspect, what I will do, I will take just two antennas for the sake of simplicity. Okay. So now to this antenna, we will have, I was mentioning, we will have phase shifters. We need phase shifters. Okay, we will first see, why do we need first of all phase shifters, and then there will be RF chain. Okay. Now let's say, this is bore site. Okay, so this is a bore site which is 0 degree. So now the first thing is that if we give um, same phase across these two antennas, let's say 0 degree, or it could be anything, like it could be 80 degree or anything like that. So then what happens, the signal from both of these antennas would travel so let me write it in a different color. So would travel uh, in the same direction like this. And what happens is that the signal, which is coming out of this, or both are in same phase. So at this point in time, both are in same phase, and they will add up. And as I was mentioning earlier, the beam would form something like this, right? Now the thing is that we need to form the beam in the different direction. So for that, let us see. Okay, I will just remove these items. Now what do we need? We want to transmit the beam, let's say, in this direction. Then, from both the antennas, the signal should travel like this. Now the thing is that um, if you carefully observe, if I draw the perpendicular bisector. Okay, so this is a perpendicular, this is a perpendicular line. So if I draw this line, then you will clearly see that, see, at this point the signal would be something like this, right? So the signal should be like this even at this point as well. So then both of them will add in phase, and the beam would be formed in this direction. Okay, let's say this angle, I am taking it as theta, a, let's say. Okay. So this is 90 degree. Then what would happen, this will become theta a. Okay. And usually there will be the distance between these two antenna, that I will call it as d. Okay. And we have this RF chain, right? We, let's say I'm using some RF signal which is having frequency FC. Basically, let's say this is lambda is the wavelength of the RF signal or the carrier. So now the thing is that what do we need to understand from this diagram? So the signal from this antenna, okay, if I want to transmit the signal in this direction, then if you clearly see, when the signal is started at this point, whereas in the first antenna the signal should travel already this much distance. Okay, it should already travel this much distance. And then once it travels this much distance, then at that point in time I should be starting the signal in the second antenna. Okay, but this is first antenna, this is the second antenna. So we have this basic concept, right? Like the signal should already travel this much distance. Let's say this distance is x. So the signal should travel x distance at antenna 1. So we have this right, like the signal has traveled lambda meters, which means that it completed one cycle. Okay, in other words, it has finished 360-degree. So there is a relation between the signal travel and the angle, right? So let's say the signal has traveled just lambda by 2 distance, which means that the it has completed already 90-degree. Okay, so signal has completed not 90-degree, sorry, 180-degree. So lambda by 4 would be 90-degree. Okay, so considering this basic concept, um, we can say that rather than, I mean, how do we ensure that the signal already travels this much distance? Basically, the thing is that the signal would travel, okay, but the signal would travel this much distance means, uh, what do we need to ensure? By the time it reaches this point, okay, by the time it reaches this point, the signal should complete its cycle. Okay, it should finish its cycle, so that from here onwards it is starting a fresh cycle, and whose phase is equal to the phase of the signal at antenna number 2. Okay, so right now the thing is that across both of these antennas I am considering the same data. Okay, s of t. That is another point. Hmm. So, as I was mentioning, we can represent this distance with respect to phase. Let us try to derive that. So, we need actually x, right? We need to calculate x. So, what is sine theta a? So, this is x by d, right? As per this triangle. Okay, as per this triangle. So now, what do I need? Um, Now, yeah. So x, I can give x is equal to d into sine theta a. Okay. So the thing is that, see, for lambda distance the signal would travel 360-degree. Okay. For x distance, what is the phi required? So phi will be given by what? Um, So phi would be 360-degree into x by lambda, right? So now we know this x. What is this x? So 360-degree into d sine theta a divided by lambda. So phi. I hope you got this. Okay, this is the phi value which we should be giving to this phase shifter, especially here. See, if you see, this is the signal at the antenna 1 is the is the one which has to travel some extra distance, right? So to this I need to give this phase shift. So here I can say for antenna number 2, 0-degree, and then I will give 5 as a phase shift to this one, so that the signal will travel in this direction, or the beam is formed in this direction. Okay, derivation is clear. Then this basic concept is clear. Then what else we need? Yeah, this phase shifters, right? So as I was mentioning in the previous video, these phase shifters, these are analog phase shifters, and these are hardware components. Okay, so now the thing is, let's say this is a phase shifter. So analog signal will enter here, and analog signal will come out of this, but with a different phase phi. Okay, but it needs a input, because we need to represent, right, how much phase to give. Then what kind of input is required for this? So maybe there are phase shifters available in the market. They are called as digitally controlled analog phase shifters. This is digitally controlled. Okay, digitally controlled analog phase shifters. So here we need to give the digital input. Now, see, this is all happening in the radio unit, right? RF section. So definitely there will be a controller which controls various equipments. So this controller would give this digital input to this phase shifter to ensure that the required phase shift is implemented. So in the so depending upon the UVs, I mean how you can analyze, how you can visualize this is, so even in the RF signal we have this. Even in the RF chain we have this power amplifier, right? Who is giving the input to this power amplifier to control, to control the power output? Sometimes we need a high power, sometimes we need a low power. Who is giving the control to this? There would be some controller, right? And that control information would be coming from the baseband or from some other control plane, right? So for a particular UV, let's say for a particular UV, we know that we need to transmit the signal in a particular direction. We have the beam ID information, or we might be having at what angle we need to transmit. Based on that, the corresponding digital input would be derived and it would be given to this power phase shifter. So accordingly, the beam would be formed in the required direction. So let's say, how to how to give those inputs. Let's say, you know theta, right? Phase shifter, okay, phi I had considered, which is 360 degree. Let's say my resolution, okay, resolution is 2 degree. So in this case what happens, 360 by 2, then somewhere around 180 degree. So 180, so 180 inputs are required, which means how many bits are required to represent 180? Like we need 8 bits. So 8 bits data could be an input to this phase shifter, so that we can implement um, entire this 360 degree, but with the resolution of 2 degree, which means we can implement 0 degree, 2, 4, 6, 8, like that. Okay, so 1 degree would not be possible in this case, but if we want 1 degree, then resolution we need to change. So then what else is required? So resolution, this thing is fine. Now we know, right? So let's say angle of arrival. So as per this angle of arrival, for example, so let's say for now I will just consider simplistic value, right? So theta a. Okay, here theta a. Let's say it is equal to 30 degree. So what is actually 30 degree? Sine. Okay, so I'm just calculating sine 30 degree, that would be off, right? So let us substitute here. So I need to calculate this 5 value. Okay, phi value is 360 into d by lambda into sine 30 degree. So this sine 30 degree is actually 1 by 2. So usually the distance between the antenna, right, in most of the cases d will be equal to lambda by 2, approximately this one. This would be the standard in majority of the cases, so I would go by that. So usually this d distance between antenna is lambda by 2. So what will happen to this equation? 360 into lambda by 2. D is lambda by 2. So this is lambda by 2 into lambda into 1 by 2. So lambda cancels. So 180 and this is 90. So which means that the phi. Okay. So 90 degree has to be implemented. 90 degree means as per this our calculation. So I have to give 8 bits, which is equal to 90 degree. So once we give that, um, then accordingly this phase shifter will ensure that a 90 degree phase shift is done. Okay, basically here 90 degree means what? The signal has just traveled you know signal has just traveled lambda by 4 distance, right? So this 90 degree, This means that, so lambda by 4, distance is lambda by 4. So I mean the signal, if signal has to travel from the very beginning, which means that what would be there here. Okay, this is not, I mean anyway the signal has to travel just lambda by 4. So I mean I'm not writing it in a proper way. So let's say if I write it clearly, then okay, let me write it here. uh, so okay, so the thing is that this, the last, see out of this signal, this last portion we should come over here. Okay. So we should start with this 90-degree phase shift. Then the signal, by the time it reaches here, it will reach here, then it is starting a fresh signal, right? So here anyway in the second antenna case, it is starting with a fresh signal, so both of them will get had. So now you got it across antenna 2. This is how the signal would have started. Across antenna 1, this from here the signal would have got started. So I hope you got the clarity. So we'll see in the next video about maybe multiple beams, and we will try to see how these things can be relate can be related to RF beams when we perform precoding based beamforming. Thank you very much. Please do subscribe to the channel. Bye bye.